Hello, everyone. I'm Mihai from Google Open Source Security Team, and you can find my socials on mihai.page. And I'm going to talk to you on this session about signing models, especially on Kaggle. So let's begin. We have, in the past 2 years or 3 years, we have a lot of development, a lot of cool AI projects. But as you know, this is the famous XKCD cartoon. There is that tiny bit down there that holds the entire scaffold. And in our case, this is the AI supply chain security. And we have a lot of problems that we need to solve. And the main problem is that in the past, when you were building models to deploy into your application, you only had 2 stages. You would train the model on your system, and you'll put it into your application. But now, because LLMs are huge, you actually rely on big companies to train the foundation models. And then you rely on somebody else. You fine-tune the models for your specific application, and then you deploy the model, the fine-tuned model, into your own app. And of course, there are 3 separate teams of people that work on these 3 separate stages. So you have the first group of ML developers that train the foundation models. And of course, here I also include data scientists, performance engineers, and so on. You also have the second group of ML developers that work more on fine-tuning for your specific tasks. And I also have experts, domain experts for your specific tasks. And then general software engineers that deploy the model into your application. In between these stages, the model doesn't go from one stage to the other via USB sticks. It actually, you put the model into some hub, and somebody downloads the model from the hub and uses it later. And now here come the supply chain risks. First, a real scenario that happened. There was, some months ago, intern at TikTok wanted to sabotage another intern, sabotage the checkpoint during training, cause the training job to crash, and start from a malicious checkpoint. And if we look at the entire supply chain diagram for models, we see there are, in every step, there are possibilities for compromise. And I'm actually going to do a demo on compromising the model storage. So let me switch to the demo tab. So right now, I'm wearing the trainer hat, and I can train a model, Python train. So this is a TensorFlow model you can know through the logs. It's the MNIST model through some small data set. I'm training some digit recognition. I trained this model, and now let me upload this model to some model hub. This is going to be a model hub that I control so that I cannot allow you so that I can show you how I can compromise it. But later, we will upload this model to Kaggle. Now, let me switch to the user. And the user is going to download the model. And then is going to use the model to do digit recognition for one image. And in this case, we got an 1 for position 8. That is the image that we showed that the user was using was an 8. Now, let me go into the model hub itself. You know, it's pink like red. I shouldn't do this. I have this script here, hack model, which I can use to tamper with the model itself. 1 second. Let me tamper like this. So it loads the model into memory, it tampers with it, and it saves it back. So if you look on this directory, I still have the same model, nothing changed. Now let me move back to the user. Let me download the model again. Sorry. Remove the old one. Download the model, and now let's try to use it. So now the user didn't know that they downloaded a malicious model. They are trying to run it. The TensorFlow still loads. And as soon as the model loads, the user has been attacked. So this is what we try to solve. And in order to solve compromising model storage, the simplest solution is sign the model upon training, and then verify it when you deploy it to the model hub, verify it when you upload the model to production, verify it when you use it when you integrate it into the application. And also, if you use this model like for fine-tuning, also verify it at that point. However, signing only protects the bits of the model. It's not enough. And to prove that, there are 2 repositories on Hugging Face that provide Llama models. One is from Meta Llama, the other one is from Facebook Llama. And if you look just at the name, you're not going to know which one of them is the real one. Sure, in this case, you can look at stars, followers, and other descriptions on the model hub itself. But all of this information can be faked. What we actually want to do is merge signature with identity. So you would know that this model has been signed exactly by this entity and at this moment in time. And for this demo, I'm going to use the Sigstore implementation for model signing, where the model training pipeline is going to connect to Sigstore to get a short certificate. which is going to use to sign the model itself. At this point, the signing event is going to be put into a transparency log, into the Sigstore transparency log, so you can inspect that. And then when you upload to the model hub, you upload the model, you upload the certificate that you used to sign, and the proof of signing, everything into one single signature in the Sigstore bundle format. And now the model hub can verify the model itself, or users can verify them if they don't trust the model hub at all. So depending on your trust scenario, you can verify at different stages. We have released a library for model signing in April, and we have all of the statistics right now. We are working on model signing under 2 different organizations. Under OpenSSF, there is the model signing working group, the model signing project. And under Coalition for Secure AI, we have working streams to improve, to extend the model signing. There is the model signing SIG and model cards SIG. And now let's move on to the Kaggle side. So let me go back to the script. As the trainer, I'm going to still do the upload script, but this time, I'm going to upload it to Kaggle using the Kaggle libraries. So it tells me that the model doesn't exist yet on Kaggle. It creates it there. It uploads the files. And if you look here, it uploaded this signing.json file, which is what Kaggle used to sign my model. Right now, before upload, Kaggle used the Sigstore flow, connected to Sigstore CA, got a certificate, signed the model, created the signature file, and uploaded everything to Kaggle. If I go on this link here to the demo model, right now, you see Sigstore status pending. Right now, Kaggle is verifying my model, is verifying the signature. And if I go down to the files, under the .kaggle directory, I can see the signing.json, which represents the signature. So I have the format of the signature. We're going to talk about this in the next talk with Ion. But what's important, this payload here, that this one contains all the files into the model. If I copy it and go to a base64 decoder and paste it in here and decode, it basically tells me that this is model signature v1, and this is the hash for demo model.keras, the file that got produced when I trained the model. And now let me go back to the Kaggle repository, and if I refresh the page, Sigstore status signed. That means that Kaggle was able to verify that the signature was valid. I didn't put a fake signature into the model. And if you don't trust Kaggle, you can go to this attestation page. This is going to show you a notebook that you can use locally to verify the signature. If you don't trust Kaggle with this notebook, you can also use the model signing library itself to verify. OK, and now let me go back to the slides. OK, so summarizing, we have integrated model signing into the Kaggle publishing libraries. We have made Kaggle a verifier for the model signing, but also users can still do that, and made Kaggle an auditor itself for the signing process. And to integrate model signing with Sigstore into Kaggle, we had to make Kaggle an OIDC provider, such that when I did the upload behind the flow, I didn't need to provide my own credentials. And also need to make sure that Kaggle has some ACLs behind the scenes to make sure that users can only sign the models that they deploy to their own account or to organizations where they are allowed to release models, such that I won't be able to upload a model and say that this is a Facebook-related model, this is a meta model. OK, in the future, we want to get into a state where we sign both datasets, models, we verify everything together, basically summarizing. We want that all claims about ML systems and metadata to be tamper-proof, tied to some identity, and verifiable by tooling that ML developers use. And if we reach this state, we can use Guac to actually build AI bombs automatically. We can inspect the ML supply chain immediately in case of incidents and so on. And thank you, everyone, for coming. I'll stop now for questions. This is the work of a lot of people. I mentioned a bunch of people here. Hopefully, I didn't miss anyone. But yeah, thank you. Questions?
If folks have questions, I can hand a mic to you. Yeah.
Fantastic work, Mihai. In this implementation, is Kaggle signing with its own OIDC identity, or is it the OIDC identity of the publisher who's uploading to Kaggle?
It's signing with the identity of the user itself. So let me go back to the model signature here. And if I look into the signature field, And I copied the transaction log entry. And now I go to Sigstore to record and search for that log index. This is the subject that gets added to the certificate. And the number in front is my user ID on Kaggle. And then at privatekaggle.com, that's on Kaggle. And so everyone that signs the models with Kaggle will have their own user ID or their organization ID.
Hi, I was wondering if the Sigstore instance is configurable. I work with folks that self-host.
Yes, so we have a PR under our repository to actually start configuring the Sigstore instance to run with the local instance. We are waiting on one release of Sigstore Python, and then we can merge the PR and release our own version for that.
So when you created the hack model and you actually corrupted the model, what happens when you try to upload it to Kaggle? Because it's still your user ID. So how does it still sign it, or what kind of message does it give, or what happens?
So if myself as the model hub owner will hack the model and sign that model on the hub, that will show on the record search on Sigstore, on the transparency log. You will now have two different signatures for the same model name. And if I am the same user on both cases, you would see that it's the same identity twice. But usually if the person that trains the model is not the person that has access on the model hub. So you'll see two separate entities signing a model with the same name. So that's why the transparency log is really important, because you can monitor all the signatures for the same name or all the signing events under your name. You can monitor either of those.